Hello friends and subscribers, welcome back to another episode of Daniel's Tech World here on YouTube. My name is Daniel Rosehill. This is my very geeky corner of YouTube where I share my tech interests with whoever is interested in watching these videos. I was away from the YouTube world for about a year. I got really busy with a work project in January. Didn't really have time to do the video editing, and I also didn't really want my leisure time to be screen time as well. So I did want to get back into it before year end 2024, hence the videos are back up now. In the year that I've been mostly away, I've probably missed, I realize, a lot of comments. I'm sure the people do not recall the comment they wrote me 6 months ago, but just to say I will be going back through those comments in order to get back to people as best as I can. So this has been the year of the large language model, the LLM, and I've been as excited as anyone else. In fact, a bunch of videos probably coming up are going to be on the topic of large language models and prompt engineering. So a lot of people, have discovered that ChatGPT is great for things like text generation and generally conversational UI. But I think that some people are still not aware that these actually have a huge amount of use cases, large language models, way beyond the conversational stuff. You can use them for parsing through large documents, data analysis, data mining, code generation, documentation generation. In fact, these are probably, for me personally, far more exciting than ChatGPT being able to write you an email. So today we're going to be looking at one of those use cases, and I think I could probably have done a blog called Use Case a Day this year, just discovering all these little things that large language models could do. Today's one's going to be basically taking a long document, a markdown document, and using a large language model to try to identify the topics within it. It's not the most glamorous use, but it is a practical and I think quite an important one. We're going to be using one of Google's models, and the subject matter is the also not terribly exciting subject matter of my GitHub repositories, because this is something that I actually use it for. I pull down my repositories and get a large language model to find the topics so I can create index pages. So let's go into AI Studio and take a look at how we can do this. Okay, so firstly, I thought it would actually make sense to show you guys the data that we're going to be working with today in this demonstration, just to show you really how capable these models are in terms of parsing text. So this is a index, as I mentioned, of my GitHub repositories. If you want the script for this, it's up there on GitHub. It basically just pulls the GitHub API, gets your repositories and writes it down to a little index page like this. Now, the reason that I generate these about probably once every 3 months is because, as you can see from the 1000 line file, perhaps I'm a total fiend at making GitHub repos, but there is generally a method to my madness. There's commonalities in terms of projects I'm working on, and I like to use Gitkraken, the Git manager, for organizing those into spaces or creating index pages. And sometimes it's just easier to do this. Actually, it's almost always easier to do this with a large language model. So this is the way the data is currently formatted, about 1000 rows. And let's see how we can use the LLM to actually do some organization for us. Okay, so welcome to Google AI Studio. It's at aistudio.google.com. If you haven't been here before, it's not the same thing as gemini.google.com. That is Google Gemini, but it is a more more user-friendly web interface. This is more of a playground style environment, but the advantage is that you can test out a lot of different Google models. Now, the reason that I chose to use Google today was because of the token limit is gigantic. If you look in the top right there, or the right-hand sidebar, just above where I am in the screen, it's 2 million tokens on Gemini 1.5, which is what I'm using today. So that is a lot to work with. So if you have something like a large document or a large inventory for your business, and you want to use this method to kind of talk through that file or talk to that file, this is a good model to use because you've got a lot of tokens to work with. And just remember when we're talking about tokens that when you input something, that's going to be tokenized. That's going to count against the context window. And then the outputs are building on top of that. So the longer you go in a chat, firstly, the heavier the work on the LLM, and the higher the chance, if you really keep going, eventually the LLM will just start putting out rubbish because the context is gone. But with 2 million, you've got a huge amount of wiggle room there. So what I'm going to do is just drag and drop my markdown file into the chat thing. And by the way, just want to say one quick tangent. This is a great way if you have previous conversations you want to inject into the LLM as context, save them as markdown, drop them in. Something really nice as well that I like about this is that it calculates the tokens pretty much instantly. So if you see there, public repos.md, 8,000 tokens. So that's just good to know, okay, how much do I have approximately to work with? So now we've basically got our markdown file into the conversation, which has all my repos. And I'm going to start running a couple of prompts to show you guys how this strategy works. Now just remember that in the original way my data is formatted, everything is jumbled up. There is no real organization. Some of these are from work organizations I'm involved with. Others are personal repos. And there's 1,000. So we've got a lot of different things mixed up here. But watch how good it is at isolating information. So I'm going to prompt like this. Please go through the attached markdown file, which contains a list of my GitHub repositories. Your task is to identify all the repositories about data visualization. List all the data visualization repositories in the format they are listed in the index file. Now, that definitely wasn't the greatest prompt that I've ever done. By the way, AI Whisper, have to give them another shout. Chrome extension, really, really useful. Great to use. So I've done a prompt here, and I actually was thinking while I was prompting, should I give it an output instruction, an output formatting instruction? You can do that when you're prompting like this. If you're generating an index page for GitHub or anything else, you can actually tell it adhere to a specific format. But I'm just gonna have it identify the data viz repos firstly. So you can see that what's happening is very good, right? It's gone through the whole document and it's identified 4 different repositories and it's stuck to the format. And if you want to get this out of AI Studio, you can just do a click here and you can choose copy out as rendered or copy out as markdown. And if you do a copy of markdown, it'll come out, of course, in markdown, but that means that it's ready for use as an index on GitHub. That was the first thing I wanted to show you guys, and this already is really useful from my perspective. I want to find ones about this or this to create an index or to group them or whatever. So let's try another prompt. I'm going to say the attached context document is my GitHub repositories. Your task is to identify all the repositories about one of the following themes: data analysis, data visualization, data mining, correlation calculations. Find all those repositories, list them in alphabetical order. For every repository, include the description in the original file and add a promotional line as if you were trying to sell someone on visiting the repository. So the reason I added that kind of little ridiculous tack on to the prompt was just to demonstrate the capability here of getting the AI to firstly do that parsing that we saw in the first prompt. And in this prompt, I just was trying to think of something I could get it to show how we can combine the text in the source file with generated text. So I don't know why I'd be selling anyone on viewing my GitHub repositories, but just in a hypothetical situation, data analysis notebook, it's picked out the repositories that match the topic. Remember, I gave it a few different data topics this time. It's returned the description in the original file, and it's come up with kind of a little promotional blurb, you know, track the global rise of outcome funds. Wow, that sounds like so much fun. So that's another thing you can do, is getting it to parse through a list and, you know, actually combine source text with second text. So we can see the token count, by the way, also displays in the sidebar. We can see we're at 9,000 tokens. Remember, we started with 7,000. So 7,000 input, 2,000 output. We still have a huge amount of tokens left to play with. So you can really iterate upon this for a very, very long time without losing context, which is brilliant. So for Google AI Studio, when I use the Google models, it's for tasks like this. Particularly, I might have, let's say, a big CSV file with a lot of data, and I want an LLM to analyze it for trends or pick out data from that. I will go to one of these models with the big context window, just so that I don't run into that annoying thing of, you know, knowing that the LLM is basically kind of choking on the tokens. What else can I show you guys? What else did I want to show you guys? Probably the most kind of interesting thing I think from this prompting strategy personally is asking the large language model to cluster things in a document into discrete topics. Now, taking this GitHub repo index and saying, okay, I'm going to make an index page. It's a bit long to have hundreds of repositories. Can you identify the top 5 themes? List those repositories, right? And that actually works well. I can, let's just get the themes in this case. By the way, I just want to say before I start, you might notice that I keep saying in the prompts, this document is my GitHub repositories. Now, I don't need to do that. It's in the original prompt. I tend to have developed mechanisms for playing it safe, especially when using less capable LLMs. And that's the reason that I do that, just to make sure it understands what the context it's dealing with is. There is really no need to do that, in my opinion, at least. But I will do it just as a fail-safe in this case. The attached document in your context is a list of my GitHub repositories. Your task is to identify the 10 most recurrent themes. A recurrent theme is a topic about which there are numerous GitHub repositories. Identify only 10 themes, list them alphabetically, and then in brackets, list the number of repositories about that theme. So I'm kind of asking you to do a bit more here. I'm saying, okay, go through it, find the 10 topics, and then calculate the number of repositories about that. So I'm getting now more interesting information here about the data that I'm analyzing with the large language model. So you can see that the output is showing, as this makes total sense to me, that I have 17 repositories about LLMs and prompt engineering, 5 on all of these other topics like backup and personal thoughts, and the 10 is absolutely spot on. This is exactly the kind of stuff I'm putting up on GitHub, typically stuff about Linux, backup, data viz, etc. Okay, so this is, again, all these little things are might seem like, you know, small feats of working with AI, and they're actually, I think, really, really significant in terms of the capabilities that they demonstrate. Another way, by the way, this is kind of a little bit of chain prompting, if you will. Thank you. Please refer to that output. I only need the list of topics and the number of repositories. Please reformat that into a markdown table with topic on column A and number of repositories in column B. So I'm just asking it to restructure that list. I didn't ask for the the specifics about the description. And let's say I don't know, I wanted this for my own index page. So you can see I've just got it to do I've just passed a basic reformatting instruction to the model, and it's given me a nice table now. So, you know, that's pretty spiffy, I would say. Okay, let's do one final prompt about topic analysis. And what I'm going to do in this prompt is ask the large language model to not identify the big themes, the stuff I'm always posting on GitHub. I wanted to identify the small little things that are maybe not obvious to me, because the big ones I can see myself. Your task is to go through the attached context document, which lists all my publicly listed GitHub repositories. Your job is to find topic clusters, small topic clusters. Each topic cluster is a group of GitHub repositories on a common theme, but there can be no more than 3 GitHub repositories for any theme. Find 10 minor topics in my GitHub list and list those alphabetically, and under each minor topic, list the GitHub repositories contained. All right, so that is the prompt. Could have used some improvement, but it's good enough for this demo. I'm going to click run again, and we can see now that it has pulled out from that initial list what I would call, you know, minor topics that I'm like, oh yeah, I guess, yeah, that is a minor topic, right? I've made a couple of repos about fonts. And again, this is the kind of stuff that LLMs are just brilliant for, because when you have, let's say, when you're working at much bigger levels of scale than this little demo, like a really big CSV data that might be approaching that much higher towards that tokenization count, and you can actually use the LLM to analyze that data. There's a lot of tools being marketed for talk to your data and all this, and some of them are very good, but you can actually achieve a huge amount of that functionality without any tools, just by going into something like AI Studio and calling up a model with a big token window, injecting your data and going with it. You can also, another strategy in this regard is to combine your data, right? So just concatenate different CSV files into one big file, pass that in, and that's my little workaround for, you know, if you don't want to go through the hassle of uploading a bunch of little CSVs or, doing some kind of a RAG system, that you can just pass one really big thing into the large language model and have it do some work around that. Hope today's video has been interesting. If you're also interested in prompt engineering and working with large language models, do feel free to subscribe. Until the next video, thank you for watching.